Alright guys, here's 5.1 video, simplify radical expressions. It's the very first objective in Unit 5. We must be really good with simplifying the radical expressions so we can progress through doing more things with radicals. But simplifying is the step number one that we need to be able to do it so we can do other things such as adding radicals, multiplying radicals, dividing radicals. So simplifying is the very first important thing. Alright, so let's first take a look at the definition that we must understand before we can go on. So when we're dealing with radicals, it's important for us to know what each things are labeled here. The value that goes here is called the index, and we talked about that in class. And the value inside of these radical is called radicand. And over here we have an exponent. So by definition, okay, one of the definitions we discuss in class is that if this value in here, this index is even, and if the exponent inside is also even, and we're dealing with a variable, we have no clue what this variable is, by definition, this is going to equal the absolute value of the variable, okay? We have to use this definition because we don't know about this variable. We don't know if this variable is positive or negative. So we must be careful and assure the use here of absolute value so the answer can be positive because we don't know what this variable is. So this is if n is even, okay? If this exponent is even and the index is even, we are going to use the absolute value. If the index is odd, we don't need to worry about any absolute value at all, okay? So I want to show you here, just for those of you that were absent and didn't understand why are we using the absolute value, okay? Why are we using this absolute value? Let me just show you an example. Let's pretend that you know secretly that x equals -1. Let's pretend you know secretly that x equals -1. So if I am going to take the square root of -1 squared, okay, I'm going to take the square root of -1 squared. Well, if I square -1, I put the parentheses in the wrong place here, okay? If I square -1 first, according to order of operations, that would be the square root of -1 squared is 1. And the square root of 1 is just 1. So there we go. Secretly, you know that x is -1. But if you tell me that the answer for this is just x, right, without the absolute value, then since x is -1, then the answer would be a -1 because that's what x is right here. But the square root of 1 is not -1. As you can see here is a 1. And these two values would only match if I take the absolute value of -1. Then 1 would equal a 1, and that works. So see why we need the absolute value is because if x is a negative value, and you're telling me that the answer for the square root of x squared is just x, it's not going to work, as you can see here. Okay, it's not going to work if you say that the answer for this is just x. It must be the absolute value of x. Okay, so it's just a little exploration. Why do we need the absolute value? As you can see here, is so the answer is accurate and is a true statement. All right, so just remember, this is the most important rule when it comes to simplifying radicals. If I have an even index and an even exponent, and we're dealing with the variables, we must use the absolute value because we don't know what that variable is. Okay, that was a discussion we had in class. Let's do some examples. All right, so here's example number 10 in your worksheet, okay? Let's start with something simple. When we're dealing with real numbers, we're interested in the principal root. So we don't deal with the plus or minus, we're only interested in the principal root. So the square root, notice that the square, it's invisible. The number 2 gets this privilege of being invisible. So the square root of 25 is 5. The square root of x squared, well, I have two x's here, and when I'm dealing with the square root, I need 2 x's. X times x is the square root. Since we have a pair, we can go ahead and take the square root of x squared is x. Now remember, even index even exponent, we don't know what this x could have been, so it must need absolute value. So the answer is 5 absolute value of x, okay? So you always have to check your little rule. Let's take a look at number 12. You have the square root, a little invisible square right here. Square root of a real number, we are only interested in the positive principal root. And then we have an even exponent. This is definitely going to need an absolute value. And we also have an even exponent. This is also going to need an absolute value. So let's go ahead and work on it. The square root of 9 is 3. An easier way for us to deal with exponent is just do the division. 4 divided by 2, the exponent 4 divided by 2, it would give me c squared, okay, because 4 divided by 2 is 2. And d would be 2 divided by 2, which is 1, okay? Now we take a look at it. We have an even index, even exponent. We're going to need an absolute value. Oh, I'm sorry, this is, I'm sorry. The rule is if even, odd, okay? If you have an even index, an even exponent, and when I end up with the odd exponent at the end. So if I end up with an odd exponent, then I'm going to need an absolute value. I'm sorry, I made a mistake here. See over here, we had an odd exponent of 1. That's why we needed the absolute value. Here, I don't need an absolute value because this is an even exponent. So whatever was negative, if c happens to be negative, because this is squared, it's going to turn out a positive anyway. So let me fix the answer, because that is not the answer. The square root of 9 is 3, and 4 divided by 2 is still a 2, and the exponent of 2 divided by 2 is still a 1. So we are looking for the even, odd exponent, because if it is even, we're safe. We don't need absolute value. So here is an even, we're good. And this is an even exponent, but I end up with an odd. Meaning if d was a negative 1, over here would have become positive, but here would stay negative. That's why we need the absolute value for d. So 3c squared, absolute value of d, is your final answer. Okay? I know it's a little bit confusing to understand all the reason why and when we apply the absolute value, but it's because we don't want these variables to be negative. We want to make sure that the answer is positive here. All right, let's move on over here. We're dealing with square root again. So we have a invisible 2 here, square root of 121. We only want the positive. So 121, the square root of 121 is 11. Then we have x cubed. So see that cubed is not, 3 is not divisible by 2, but I can definitely break this out and write it as x squared times x. Okay? Now I know that a 2 is divisible by 2. That gives me an x. So I can take the square root of this. But this other one over here, we can't. So I'm going to keep it inside of the radical. Now 12 is divisible by 2, and that gives us y to the 6th power. So our answer is 11 x y to the 6th times the square root of x. Now let's check. If x was a negative number, it would have been negative here. So square, even index, odd index, we don't worry about it. Remember, the rule is even, odd. So even, odd, we don't mind. This does not need an absolute value. But even here, but we end up with the even here, it's okay. The rule is even index, even exponent, and you end up with an odd exponent. That's what we need to be looking out for, okay? So we checked it, everything is okay, and our final answer is 11x y to the 6th times the square root of x. That is our final answer. Okay? All right, let's do one more. Now this case, on number 16, we have a 2 outside. This is 2 times the square root of 24, a to the 4th power, and b to the 9th power. So let's go ahead and write the 2, because the 2 is waiting to multiply whatever things you bring out. Okay, 24, let's look for perfect square numbers. When I see a 24, I see a 4 times 6. So I know I can take the square root of 4, but I cannot take the square root of 6. So I'm going to go ahead and take the square root of 4 is 2, but I'm going to put the leftovers back inside of the radical right here. Square root of 6 has to stay inside. 4, a to the 4th power. 4 is divisible by this invisible 2 right here, and it gives us a squared. 9 is not divisible by 2, but I can rewrite this as b to the 8th power times b to the 1st power. It is very equivalent. B to the 8th times b to the 1st equals b to the 9th. So I know I can take the square root of b to the 8th. 8 divided by 2 is b to the 4th. So I can take the square root of b to the 8th, but this b to the 1st power is going to have to stay inside. So we took care of everything. Now let's go ahead and check if we need absolute values. We have an even index, we have an even exponent, we ended up with the even exponent for the variable a. So we are okay, we don't need absolute value. We have an even index with the odd index that automatically I don't need an absolute value. So our final answer is 2 times 2 here needs to be simplified to become 4, a squared, b to the 4th power times the square root of 6b. And that would be our final answer. Okay? All right, let's do one more. Let me see if I have more examples. I have 2 more. Let's do this one right here. This negative 3x is a value outside, so I'm going to rewrite it, negative 3x times whatever I can take the square root. This is a squared. So I'm going to take the square root of everything I can here. 81 is 9 times 9, so we can definitely take the square root of 81, which is 9. X to the 7th, I'm going to write as x to the 6th times x to the 1st. I can go ahead and divide 6 by 2, which is x cubed. But I can take the square root of x to the 6th, but the x to the 1st we can't, so we're going to keep it inside. We have y squared. A 2 divided by 2 is 1, so we have our y to the 1st power. And there we go. We got everything nice and cleaned out. We simplified the radical. Now we have this negative 3x outside waiting. So we multiply coefficients times coefficients. So negative 3 times 9 is negative 27. And x times x, we can multiply the same variables. There's a rule of exponent that says when you're multiplying the same base, you add the exponents. So this would be x to the 4th. And then we have our y to the 1st power. And then we have our square root of x, the one that couldn't come out. Now let's check if we need absolute value for anything here. Well, this is to the 4th power, so we're okay. Let's take a look at the y. We had an even index, an even exponent, but we end up with an odd invisible number 1. So that needs an absolute value. So we're going to apply an absolute value right here, and that will be our final answer. Okay? All right, let's do the last one over here. We have a 3x squared. Okay, this 2 belongs to this x outside. So we have a 3x squared. Let's open parentheses. Let's simplify everything that we can possibly take square roots from the radical, and then we'll take care of it. Okay, so we have an invisible 2 right here. It's a square root. 40 is 4 times 10. I'm always looking for perfect square numbers. I can take the square root of 4, which is 2, but the 10 is going to have to stay inside. I'm going to make a little radical here for 10, so I don't forget. The x does not have enough. It's to the 1st power, and there's not enough x's to make a double for me to be able to take the square root, so that's going to have to stay inside as well. Y to the 4th, we can definitely get the exponent of 4 divided by 2, which will be y squared. Okay? So now we are simplified everything out of the radical that could come out, and what it couldn't, we put it back in. Now I need to multiply coefficient times coefficient. 2 times 3 is 6. X times any other x's, I don't have it. That is outside, I don't have it, so it will be x squared. and y, there's no more y's to multiply, so it would be y squared times the square root of 10x. Okay, everything here is even power, so we don't need absolute value. That is the final answer. Okay, so simplifying radicals, as you can see, even I've been doing it for a while, I still get confused. So you have to really be careful and double check your work to make sure that we can apply the rules carefully. Okay, so that is how you simplify radicals. Good luck finishing your worksheet, and make sure you apply the rule of even index, and you have an even exponent. Okay, but then you end up, after you take it out, you end up with an odd exponent. That's when you need the absolute value. Okay, that's when you need to use the absolute value of whatever is the variable you're dealing with. Okay, so that is the rule that I really want you to pay attention throughout this whole unit whenever we're dealing with variables. So good luck.